Alright guys, excuse how awkward this setup is. I'm below the board here. This is my whiteboard in the house, so we're going to do the best we can. Alright, so if you are in my 8 a.m. class, this will be review. If you're in my 9 a.m. class, this little piece here will be new to you. But what we finished last time is, remember we are modeling firms in the short run. And so in the short run, capital is fixed, but labor is variable. So if the firm wants to change output, increase it or decrease it, the only thing they can do in the short run is hire more workers or fire more workers. And so we traced out some cost curves that corresponded to short run production costs. And so you should have a graph in your notes that looks like this, where we drew our marginal cost curve and we learned of a concept called marginal leads the average. So we now have an average total cost curve that's U-shaped, and the marginal cost curve goes to the minimum of that. The other thing to notice is that average variable cost is the same. Average variable cost is also U-shaped, and marginal cost crosses it at its minimum. And notice that I've made it get closer here to average total cost, and it's further away here. That's because these relationships here mean that when we have any two other curves, we can solve for the third one. Total cost equals fixed cost plus variable cost. Average total cost equals average variable cost plus average fixed cost. If you look at the table that we completed in class that's at the back of your worksheet, you'll see the average fixed cost just decreases, right? It doesn't change with how much we produce. So on average, fixed costs are very large if we don't produce a lot of stuff, and then as we tend to produce a bunch of things, they get smaller. And so that's what happens here is we technically have an average fixed cost curve that looks like that, constantly decreasing. But one thing you'll notice is that the difference between ATC and AVC at any given quantity, for example here, that's average fixed cost, right? The height of this curve at that quantity is average fixed cost. It's the same as the difference. That difference is small over here and then big over here. So most of the time we're not even going to draw the average fixed cost curve on there. Once again, if you have any two of these variables, you can solve for the third one. So this is going to be our model of a firm's costs in the short run, and it's going to be very useful for us to figure out the profits that a firm might make. And so when a firm is maximizing profits, they're choosing how much to produce to gain revenues, given that when they produce more stuff, they get more costs. Well, those decisions tend to differ whether they're making a decision about what to do tomorrow versus what to do, say, a year from now. And so what we're going to do next is differentiate short-run production decisions from long-run production decisions. In the long run, capital and labor are variable. So I know it's hard to see it there. So capital and labor, K and L, are variable. And so I'm going to tell a story and draw a graph that illustrates a firm's long-run decision making. And the particular industry I'm illustrating has what's called diseconomies of scale. Let's do just economies of scale. The other way to think about, the other name for this is increasing returns to scale. Those two things mean the same thing. So either economies of scale or increasing returns to scale. And so what economies of scale means is that costs fall as output increases, particularly average costs. So average costs fall as output increases. What does that mean in words for us is, remember, average costs are an approximation of our unit cost, how much it costs per unit to produce something. So if we become bigger and our unit costs fall, then that's good, right? It's easier, we'll make more profits if our costs per unit are falling. So here we go. We're going to model economies of scale. This is a long run decision, and I'm going to, for comparison, talk about the short run as well. So let's get a short run average total cost. Here on a short run average total cost, and we can put a marginal cost curve through it if you like. Check yourself that when you've drawn that, you have marginal cost going through the minimum of the short run average total cost curve. So this is what a firm looks like in the short run. And let's say they're currently producing at Q0. So they're a relatively small firm. Well, suppose the price in this market, I'll put P, is there. We haven't really talked a lot about the profit maximization decision yet, but that's okay. What this is showing us is that, hey, this firm's unit cost at Q0, average total cost 0, is above the price. So on average, we're making a loss there. We're charging a price below our average unit if we produce Q0. Well, one thing the firm can try to do to lower their costs is hire more workers and let them specialize. We saw a portion of the total product curve where workers became more productive as we hired more of them. Right? They were able to specialize, like the pizza place we were talking about. And so let's suppose that this firm hires more workers and increases the size of the output, so they're going to produce more stuff. Well, they'll march maybe down here to Q1. We notice that that is the minimum that their unit cost could possibly get to on average, and they're still not making profit. So in the short run, hiring and firing workers isn't going to get this firm to make profits, and that's not good. Well, fortunately, in the long run, the firm can choose to change K as well as L. So instead of staying in the small establishment that eventually stops our workers from being increasingly productive and makes our costs start growing, let's build another place. Let's get bigger. That way when we hire more workers, they too can specialize instead of running into one another. And so when that happens, when you can change capital, let's suppose we get into a bigger establishment and we allow our workers to specialize. What that does is it shifts us down to a lower, I call that one naught if you want to, and that one 1, to a lower average cost curve. Right? All the workers become more productive because we changed the capital that they're able to use. So it's like, imagine a pizza place that is full and everybody's bumping into each other and they're not able to produce as many pizzas. And then you buy the place next door and the kitchen just opens up and there's all kinds of room. Every worker becomes more productive as a result of that capital increase, and they're able to specialize and produce more output. And so we call this economies of scale because if you notice, as the firm increases in size, they can get right here to that minimum and then hop onto another short run average total cost curve by changing capital and not just labor. Now they're in another short run. They've made their capital decision, they've leased another building for another year, so the only way they can grow is hire workers. And they do that until they can get down to the minimum here, a short run average total cost again. So we'll call that Q2. And then what happens if they keep hiring workers from this point? well, their cost starts to go back up again, and they don't want that. But in the long run, what can the firm do once again? Change the amount of capital and fixed inputs that they have. And so the firm that is in this industry that can increase output and have average total cost fall, we call that economies of scale. And technically there's an infinite number of those short-run average total cost curves that firm could get at by just choosing different combinations of labor, capital, and size. And so if we want to draw a line connecting a place on all of those curves, pardon me, I'm going to grab another color marker to help with this. If we were to draw a line that connects, it just touches all these short-run average total cost curves, this is called the long-run average total cost. Long-run average total cost. I don't have room to write this, but you write this in your notes. The long-run average total cost curve is a locus of points. It is, let me say it differently. It is a line that touches a point on every single possible short-run average total cost curve the firm could reach. And so, yeah, we could draw even another one that went like here. Right? And all in between there. Now, this long-run average total cost curve, a mistake students make a lot is they think it touches the minimum of all the average total cost curves. It's not true. It just has to touch one place on a short-run average total cost curve. And so firms have control of the size of the firm, and they can grow the firm by either, let's remember, quantity equals some function of capital and labor. So they can increase labor or they can increase capital to become a bigger firm. In the short run, they can only do it with L. In the long run, they can do it with K and L. And it turns out firms that are in economies of scale industries have decreasing costs when they choose to scale up their business. And so an example of this type of firm, let's see, where I haven't written yet, is manufacturing. We see economies of scale most often in manufacturing. Think about the manufacturing firms you remember. They're large, right? They're not small establishments. They're large, capital intense, or not, I say they have a lot of capital, right? Large building, so they can fill it with their variable inputs, and these variable inputs can be specialized and very productive. Okay. So, economies of scale. Long-run average total cost curve falls as Q increases. Another way to say it is if Q doubles, long-run average total cost less than double. So suppose Q and long-run average total costs, Q goes from 100 to 200. Long-run average total costs go from 100 to 150. Or, sorry, if Q doubles, total cost less than doubles. Pardon me, make that change. If Q doubles, total cost less than doubles. So down here we have Q and total cost. The reason why I had to make that distinction is what's average total cost here? Total cost divided by Q, 100 over 100, cost us $1 per unit to make that good. If we scale it up and we become a bigger company, doubling our output, total costs don't double. And so this is 200 over, or sorry, 150 over 200, it's going to be 0.75 per unit. Average total costs are falling, just like we drew with that curve. All right. In the long run, when firms can choose capital and labor, they might also choose to be a small firm. This would be an example of firm in diseconomies of scale. Diseconomies of scale, or decreasing returns to scale. Decreasing returns to scale. Same thing, you'll hear them both ways. What diseconomies of scale looks like is long run average total cost increases as quantity goes up. So firms that get big start seeing costs go up. Manufacturing is usually a product that can be produced in parts, and division of labor works out. This type of industry is going to be one where the quantity of the type of good produced either cannot be divided into parts to be made, or suffers from quality. Quality suffers when you try to scale up. And so let's see if you can draw it. Just a challenge. On this axis, pause the video and see if you can draw what you think diseconomies looks like. You just drew economies. What does diseconomies look like? Okay, let's suppose we have a small firm, Q0. They're going to be on some low short-run average total cost curve. And so they can hire workers to lower their costs down to that minimum. If they continue to hire workers to increase output, their average total cost will go up and start working against their profits. However, in this type of industry, if the firm tries to become bigger, let's get a bigger building so that we can hire more people and let them specialize, we actually see that their short-run average total cost curves go up. An example would be hospitals. Those of you who are in a small town, think about how many hospitals you had. Probably just one. Those of you who are in a bigger city, do you still only have one hospital that's super large? No. You have many hospitals that open up to try to service patients. So why might that be the case? If you have one large hospital, you get a bunch of coordination issues. Doctors trying to get across large areas to service patients, and lots of middle management hires that don't really add to productivity, but they're just coordinating activities. And so it becomes difficult to maintain the quality of the good and make this the same queue without increasing cost. I mean, sure, you could let people, you could shirk on your treatment of individuals, but then you're not offering the same good technically because it's lower quality. So to maintain the high quality of the service, your costs are going to explode. And so this type of industry, we would see a long-run average total cost curve that looks like that. Cool? So as this firm gets bigger, in the long run, by changing their capital, not just their labor, we see that they become in these higher cost short-run situations. So if we had a price in here, if we had a big firm, they would be making a loss, right? Their unit cost would be above the price. Instead, we want to be a small firm, keep our costs low, and make profits. And so maybe hospitals are non-profits, but you get the idea. If we want a mathematical example of this, secondary definition is that doubling output more than doubles total cost. So quantity 100 to 200, total cost 100 to 400. What's happening to ATC here? Total cost divided by Q, 100 over 100 is $1 per unit. If I become bigger, thinking that's going to decrease my unit costs and help with profit, I would be wrong. Total cost over quantity is $2 per unit. So becoming larger makes my costs grow in this type of industry. All right, that's all we're going to do for the online lecture. Hope you took good notes. When we get back on Monday, I'm going to cover one more type of industry and fill in some gaps here, and then we're going to watch Shark Tank videos and try to guess what type of industry the people are working in and how this kind of influences real-world profit maximization decisions. So if you want to have a good lecture on Shark Tank, you want to make sure that you understand this stuff. Don't forget now to go on Georgia View and take the quiz. It's not timed, but you do only get one chance. All of the answers are in this video. Have a good weekend, y'all.